Hi, welcome back. We are talking about section 2.3 right now, which are section 11 of the notes, and it's page 30 in your note guide. So go ahead to 2.3, deductive reasoning. This is the second type of reasoning we have discussed. The first type was, I believe the first section of notes was inductive reasoning. So we have inductive reasoning and deductive reasoning. So we'll introduce that and talk about it later after our warm-up. Here are two warm-ups. So again, you should pause the screen, see if you can set up and answer the warm-ups, and work them out. Can you guys do it? Okay, hopefully we can. The first thing I want to point out right here is warm-up number 1 is a big deal. You will see it. Every time I set it up, I always remember that I want to start with two equations. I like to start with two equations every single time. Now my first equation is A is. That means that angle A is equal to 14 more than. More than is going to be an addition problem. 14 more than means it goes behind. More than, greater than, less than always pushes that number behind. 1/3 of its complement. The complement is the variable. I'm going to use C for the variable. Again, you can use other variables. I'm going to use C. So I'm going to say more than 1/3 of whatever C is. That's my first equation. Now it says, what is the measure of A's supplement? Well, we're going to get to that at the end, so we actually might have three equations here. But I know that I have A and I have a complement. That's going to help me figure out my second equation. Angle A and whatever the complement is has to add up to 90 degrees. So if we remember that the complement is 90 degrees. Here are my two equations. I know what A is right here. I'm going to take this value for A and I'm going to plug it in right here. I'll go ahead and use my orange pen because I highlighted that orange. I'm going to say 1/3 C plus 14 plus C equals 90. Okay, there are different ways that you can do this. Probably what I would do first is just to simplify a little bit. I'm going to subtract 14 over. So I have 1/3 C plus C equals 90 minus 14. I get 76. Now I have fractions, and I prefer fractions to decimals most of the time, but I still want to get rid of them. So in order to get rid of the fraction here, I am going to multiply both sides by that denominator. I want to clear the fraction. If I multiply everything by 3, I'm going to be able to get rid of that. So when I distribute that 3 here, I end up with C plus 3C. Now, to simplify on myself, and if I don't have a calculator, and I know you guys do at home right now, but if I don't have a calculator on the test, I'm probably just going to write 76 times 3. Because it's going to leave my numbers a little bit more manageable for me. This is 4C equals 76 times 3. I'm going to divide both sides by 4 here. And I know that 4 goes into 80, and that's 4 away, so 4 is definitely going to go into 76. That's going to be more manageable than multiplying those two numbers together. So if I do this, 4 goes into 76, 19 times 3, I end up with C equals 57 degrees. Again, you can always go do 19 times 3, 27, okay, 57 degrees. But again, going back to the question, is that what they asked? They asked you to go ahead and find a supplement. Well, if this is the complement, I'm going to have to figure out what A is and say that A plus the supplement is going to equal 180. So I've got to either subtract 57 from 90, or I can plug it in. I'm going to subtract from 90. I'm going to say 90 minus 57. I end up with 33 degrees. This is my measure of angle A. So once I know that, now I can find that last step and say that, okay, well, A is 33 plus the supplement equals 180. Subtract that, and I get the supplement is 147 degrees. This is definitely, it's a multi-step problem. You've got to really know what they're asking you, set up your two equations. Once you find that, realize that you've got to do a few more steps. So good luck. Hopefully you guys did well on that. And again, pause the video, do this next one, the factor. This one is factor by grouping. So whenever you have 4 terms, you want to group 2 of them together and see if you can factor out the common factors. I usually underline the 2 in the front, underline the 2 in the back, and I color code this usually. I like to use a lot of colors. All right, so I'm going to factor out 3a squared. Go ahead and put my parentheses here. Back here, now whenever there's a negative in that first term in the back, you really want to factor out that negative. I'm going to factor out a negative 5 and be left over. 3a squared times, 3a squared times a, 3 times negative 4. So this should match. So I'm going to assume this is an a. Negative 5 times a is negative 5. Negative 5 times negative 4 is a positive 20. If I had not factored out a negative here, it wouldn't have worked. So always make sure if it's not working, but it's really close, did you need to factor out a negative? I didn't leave a lot of space, I would kind of big. So remember, these two have to match or you did something wrong. You want to factor those out together. You end up with a minus 4. And then the other factor are the 2 in purple that I already factored out, 3a squared minus 5. Oh, apologies, I wrote a little big there. But those are your last 2 factors. Hopefully you guys do well. Good job. Okay, so here we're going to start deductive reasoning. We have symbolic notation, and I believe we already did our conditionals. And we're going to go a little bit more in depth with them. We talked about symbolic notation, if P then Q. This is my conditional. And then if not P, then not Q is when I keep it the same and I negate it. So when I keep it the same and I negate it, that one's called my inverse. Now, the contrapositive, however, is when I keep it the same and I'm going to flip it and negate them both. So flip them and negate them both is going to be if not Q, then not P. Okay, we want to let P be the value of x is negative 4 or positive 4, and Q is the square of x is 16. I want to write this out in an if-then statement, and I want to decide if they're true or false. Okay, I'm going to go ahead and pause my screen and fill it in for you. You go ahead and pause and fill it in as well and see if you set it up correctly. So I highlighted a few of those. So I made my P, the value of x is negative or positive 4. The square Q is square of x is 16. I wrote my conditional here, my converse, so I remember this is conditional if P then Q. Converse is if Q then P, and I color coded that so I can kind of follow along. If, and I'm going to write it this way, I'm going to say if x is equal to plus or minus 4, then the square of x is equal to 16. That makes it a little bit nicer to write, actually. If x squared is equal to 16, then x is equal to plus or minus 4. Now I have to decide if these are true or false. Well, if it's positive or negative 4, positive 4 squared, negative 4 squared, yes, that is true. Well, if x squared is 16, then x has to be positive or negative 4. Again, that's true. So remember, if both the conditional and the converse are true at the same time, you can write P, do you remember that arrow back and forth, is called your if and only if. So P, if and only if Q, this is known as a biconditional. Okay, or if it's not, if they aren't both true, then you want to give a counterexample. Well, in this case, they are both true. So I'm going to write, always write your P first, if and only if, your Q. Now, if they were not both true, you would write a counterexample saying why they weren't both true. But in this case, I'm going to say x is equal to plus or minus 4 if and only if x squared equals 16. So that means it works in both directions. Okay, so this one down here has that big word when, and I know we talked about this the other day in our notes, so you have to remember what this means when you set up the problem. So hopefully I'm giving everybody a chance to do that. Pause your videos, fill them in, come back, and hopefully everybody remembers that when we see that word when, it really represents our if. Okay, so if I'm going to write P then Q, my actual conditional statement over here, my original conditional is going to be if it is Monday, then there is school. And again, I'm abbreviating, I don't have a lot of space. Okay, so we want to write these conditional statements. What is this one? If it's not P, then no. If it's not Q, then not P. That was flipped and negated. This one would be our contrapositive. This one is if not P, then not Q. This is negating the original. This one is called the inverse. So I'm going to go ahead and pause the screen and fill this in and then come back and check it. So again, I highlighted the P's orange and the Q's green. I said if Monday, then school. When it's Monday, then we have school. Now, I also put the negation in as the little squiggles. So if there is no school, then it is not Monday. Well, if there's no school, does that mean it's not Monday? Well, yeah. If there's no school, you definitely know it's not Monday because every Monday we have school except for last Monday for Labor Day. But in general, we're speaking about most weeks. In general, our regular weeks. If we don't have school, then we know it's not Monday. So yeah, this is a true statement. Now, what about if it's not Monday? Then does that mean we don't have school? Well, that one it's false. If it's not Monday, it could be Tuesday, Wednesday, Thursday, Friday. That one's a false statement. These are not both true. You could not write a biconditional with those because they aren't both true. And they're not the converse conditional. Okay, so our next definitions here, deductive reasoning and inductive reasoning. We've already discussed inductive reasoning. Inductive reasoning, if we remember, is when we are looking for patterns, and I always use the word observation. So you're observing and you're looking for patterns. And then I remember that this is an O and this is an I, and those are both vowels, so the vowels go together for me. Inductive, observation, observing, and looking for patterns. The other form of reasoning that we learned today is called deductive reasoning. Now our deductive reasoning is really based on facts. So deductive, facts, those are both consonants, those go together. So I kind of remember that the consonants go together, the vowels go together to help me remember which form of reasoning is which kind. Okay, we are going to go to the next page. There you go. Read through these. I always think these are kind of interesting. Is the reasoning inductive or deductive? So read through them and decide. Did I use orange and yellow? Okay, so deductive was yellow, inductive was orange. Okay, Josh knows that all brands of computers, that brand X of computers costs less than brand Y. All other brands that Josh knows of cost less than brand X. Josh reasons that brand Y then costs more than all other brands. So right here, Josh knows that X costs less than Y. I'm going to write myself a little note off to the side. And then he reasons that brand X, he knows the cost, all other brands that Josh knows of cost less than brand X. So then Josh reasons that brand Y has to also cost more than all other brands. Okay? Now, what kind of reasoning was that? Was that inductive or deductive reasoning, and why? What word would you have picked here? Or phrase? This one I am going to say is inductive because it says that he knows of. So because it's what he knows of, there could be other ones. It's what he's observed. So it's what he's seen, it's what he's observed, it's inductive. It doesn't mean all of the other ones in the entire world for sure, it just means what he knows of, so that's what he's seen. So this one's going to be inductive. Now the next one, Josh knows that brand Y computers cost less than brand Z. So now Josh reasons that, well, brand X is going to cost less than brand Z. Well, because he already knows this up here. And he knows this. This is a fact. And he knows this, making it a fact. So he can reason this using deductive reasoning. Okay. So those are two different types of reasoning. It's whether or not he observes and knows the pattern, or if he knows it because it's a fact and he knows it for sure. Okay, these next two here, laws of detachment and laws of syllogism, they are definitely things that kind of throw us for a loop, and we just have to remember the pattern. We have to remember just how does it match together, how does it work, and stick with that thought process and idea. Okay, so the actual laws, they're a little bit tricky, but you just have to remember and match the pattern. I'm going to color code them, I'm going to cross them out, I'm going to show you how I connect them, and that's what you have to memorize, that process. Right here we have to know the process. Okay, so the law of detachment, I'm going to use green and yellow for the rest of this. Alright, so green and yellow highlighters. Law of detachment. I'm going to go ahead and highlight the word detachment on those next two in green. Law of detachment, if P then Q is a true conditional and P is true, then I know Q also has to be true. If P then Q and P is true, then Q is going to be my answer. Q, it has to be true. Okay, now my law of syllogism, and again I'm going to highlight those in yellow down here. Syllogism is going to link it. It's a transitive property. Can we link them together? If P then Q and if Q then R are true conditional statements, then because Q is here and Q is like my middleman, because Q is the middleman, I can jump from P to R and say if P then R. So you're going to connect the very beginning to the ending because the middle matches. They're like little tinker toys that match together in the middle, so you're really just worried about the end pieces because you could link them all together. Alright, so using these true statements to write statements, using the laws of detachment and the law of syllogism, here are a bunch of statements. I'm going to start with syllogism because it was first here. Syllogism is when you can link a beginning and the end. I want a beginning piece to match an end piece. So you don't even want to look at E and F because those are just words. You want to look at the actual conditional statements, the first four. Is there a P that matches a Q? I have pizza, I have two milks, but they're at the end. I have two pizzas, one's at the beginning, one's at the end. I can connect those. Now when I connect those saying, well, if it's Friday, then pizza, and if pizza, then soda. And I can connect those, and I can drop the middleman. So my statement here is going to be, if it is Friday, then have pizza, and if we have pizza, then we have soda. And I don't even include the pizza. Don't even write that middle piece there. Just drop it all together and connect the rest of that, like I call it a snake. If I can snake it together, you can drop the middle name. Okay, so now that's my syllogism. The next one is detachment. Detachment is where I want to take these words by themselves, and are they a P? So is pizza a P anywhere? Yeah, pizza's a P right here. If pizza's a P, what is my conclusion? Because if the P is true, then I know the Q is true, and the Q right here would be my answer. So if pizza's true and pizza, then I know soda has to be true. All I write for detachment is soda. And I'm done. That's it. Don't make it crazy. Don't make it too hard on yourself. Over here I start with P. Or milk, sorry. Is milk a P? No, it's a Q. This is not a P. Not at the beginning. If it's not at the beginning, you're done. You just leave it alone. That's it. Now, it's just a process. So right here, it doesn't even matter if you can speak this language. I think it's French, right? I can't speak it. It doesn't matter. I don't have to know it. I just have to be able to link it if I can. Pause the screen, see if you can do what we just did above, and you get the correct answers. I'm going to continue on. Also notice that detachment and syllogism are in a different order, so you've got to pay attention to that when it asks a question, and will not always ask you in the same order. I'm still going to start with syllogism first, because I like to. So I'm going to say, do I have a beginning and an end that match? Well, yeah, I have this one right here. Matches this right here. So I can go ahead and write and again I can take my and snake it together and you drop the middle. There, you're done. And look, over here, I also had a P and a Q that match. The beginning and an end that match. So again, I can still take this. So I can have two sometimes. And now I'm going to say, well, if star, then smiley face. So again, you're just mashing the P's and Q's. That's your syllogism. It's like your transitive property of P to Q, of Q to R. Match the very beginning to the very end. Now I want to see if any of these are P's. So I'm going to start with this one. Is this a P anywhere? No, it's a Q. So I'm not going to use that one. I'm going to go over here. Is this money sign, is this a P anywhere? Yeah, it's a P right here. Which means my final answer here is just going to be smiley face. There you go. You're done. Just that's your final answer. Okay, so again, don't make that harder on you than it has to be. Remember, memorize the process, and can you link them together? Okay, you guys got this. Good job. Keep it up. I'll see you guys later.